I first gave this talk in 2008 at PHP&W, and a lot's changed in the last 5 years. When I gave this talk 5 years ago, PHP 5.2.6 was the latest release, and CodeIgniter was used seriously, I think. Sun owned MySQL. It's that sort of an era. So I've rewritten the slides from scratch, and this version has a greater emphasis on diagnosis right at the start, how to find out which queries are causing your problems. So, right, we're going to do this. I'm going to do it without notes. Which is a bold move. My name's Adrian Hardy. I've been writing business critical systems for about 10 years now. I've been working with Jeremy for the past 2.5 years at Magma Digital. I've been their dev team lead. For the grammatically astute amongst you, I'm using the past tense. That's because as of October, I'll be the managing director of my own company. So Jeremy had to expect me to do that, I think. So it's been great to work with Jeremy, and if you want a job in a really progressive environment where you get to tackle cool problems, go see Jeremy. If you have any work, come see me. So, what are we going to try and achieve today using MySQL Explain? Make stuff faster. Who doesn't want to make stuff faster? With Explain, you will have the opportunity to make optimizations incredibly quickly. The cycle from finding a slow query to making it 100, 200, 300 times faster can be about 5 minutes. And Explain gives you a head start on where to go to make stuff faster. The other key thing that we're going to try and do today is shield the calling application from any changes. Making an optimization is no good if you say to developers, right guys, I've made it 10 times faster, but you're going to have to rewrite everything. If you can make changes without anybody having to do anything, everybody's going to be much happier. So, the first step is identify. Excuse me just a moment. There we go. The first step is to monitor the changes that you get, the queries that you're going to need to make a change on. The next step would obviously be to make those changes, and the third step would be to monitor them. What effect have we had? And there's a whole set of tools that you can do for identification of slow queries. Really, really simply, if you're in MySQL, you happen to be in MySQL, and there's a query not completing in time, show full process list will show you the currently running queries and how long they've been running. This is a bit of a low-tech solution, right place, right time kind of solution. The /G on the end, incidentally, makes MySQL format its results vertically rather than horizontally, so that's kind of handy for this sort of diagnosis. But that's a pretty terrible way of doing things. So what we've got from the command line is atop and top, or if you like coloured graphs, htop. They will show you server load. You'd be able to identify if the cause of the slowness is Apache or MySQL. If you have the luxury of being able to partition up your drives before you start a project, I would recommend that you go pretty heavy on the partitioning. So have one for your web data, have one for a temp, and have one for MySQL data. That will help you narrow down performance issues using tools like atop, or even top, because it will tell you which partition all the writes are going to, and then you get a clue. The best solution really is the slow query log, which is a feature built into MySQL, which we'll be going through in a few minutes. There are a couple of other custom tools, which I'll go into in detail as well. PTIO profile is like IOstat, if anybody's familiar with IOstat. It shows statistics about disk usage. And PT Query Digest is awesome, and we'll get into that in a few minutes. Much of the first part of this talk feels like it's sponsored by Picona. It is not, but they've basically patched up MySQL, and it's a drop-in replacement for MySQL, meaning you can uninstall MySQL, leave your var-lib MySQL in place, install Picona over the top, and nobody will know the difference. However, it has lots of cool diagnostic tools and performance improvements. They're only a couple of weeks or even a month behind the main release, So you're never waiting for too long when MySQL or MariaDB release some code. Those guys will be on it fairly quickly, and it's packaged up into RPMs to make everybody's life easier. This question came up recently for the risk averse. You can use the tools I'm about to show you in a development environment if you're not comfortable changing out MySQL or MariaDB on your production environment for something that, just because I'm saying you should do, you can use it like a static analysis tool, if provided you can get the live data locally. Configuring Percona slow query log. If you can MySQL slow query log, you can configure the time after which stuff starts to get logged, so it's like 1 second, 2 seconds. There's a lot more configurability with Percona's slow query log, so you can say what sort of slow queries should be logged out. Was it if it was a full table scan or a temporary table on disk, only those will appear. And just put log slow verbosity equals full for, I can't see a reason why you wouldn't want every bit of information that Percona has to offer on a slow query. So those are the statistics that are available with the bog standard MySQL install. Not a lot. You can infer a fair bit there. You can say, well, if rows examined is 2 million and we sent back 1 row, something's wrong. If the query time took 60 seconds, something's wrong. Of course, if you're running the query once a day and it takes 3 minutes and it's in the middle of the night, who cares? You know, there's a bit of judgment that you have to apply here. The Percona version gives you a lot more information. I haven't even listed all of it because it would have gone off the bottom of the slide. You've got the same data, but for example, you've got, did it hit the query cache? And for those who don't know how the query cache works, my understanding is, if like the, for want of a better phrase, the MD5 fingerprint of the select, if it matches and it has that result set in the query cache, it will send that back. So if you send the byte for byte same query, one after the other, the query cache will be used. And it would say query cache hit yes. So you know that that's a particularly performant way of doing things. However, the query cache is invalidated every time you write to a table. So if you do a query, it goes to the query cache. As soon as you write anything to that table, not even the row or the result set that wouldn't affect it, the query cache is invalidated. So for example, if you're constantly getting query cache hit no, then maybe it's a write-heavy table and it's pointless trying to build up the query cache. So you should lower your query cache size from 128 meg to 16K. Just don't even use it if you don't have to. And then there's other things like, was a full scan used? Did it make a temporary table? Did the temporary table go to disk? Loads more statistics that let you get a real insight into how MySQL is working. Here's an example output from, it's lower resolution, so it's a bit jumbled up, but you also get the query, the offending query itself, as well as all of this metadata. That was just taken straight from their documentation. Oh. This is the PT digest clipped helpfully, so you're missing about the remaining third of it. There's some really good information in here, and this is done over summary form. You can use PT Query Digest, which is a tool released by Percona. You pass it your slow query log, and it will summarize the information. It will give you, from 1 to whatever, the top slowest queries for you to tackle. So I think this was the third most slow query on this particular system. And it gives you some really, well, you know, for example, what the average query time is. You know the fact that the lock time was low is that it wasn't a write contention issue, it's something else making the query slow. And if you just look, for example, the difference between rows examined and rows sent, 6 million rows examined and 313 sent back. That's something to tackle. Why on earth is MySQL examining 6 million rows to send back 300? That's an awful percentage. That's something we should be looking into. And you can also see that every damn time it went to a temporary table and every damn time it went to disk. Temporary tables don't necessarily always go to disk, but if they are always going to disk, you can't assume that disk is an uncontended resource. You have to assume that other things will be using it. So if you can stop stuff going to disk, you should do everything you can to prevent that. Right, improve. And I've forgotten my notes for this one, so I'm just going to skip on to the next one. You prefix your select query with explain. And that's it. That's how you use explain. You take your select query, stick the word explain in front of it, and you see the output. It's relatively instant. If your query takes 30 seconds to run, you can expect that explain will come back in a fraction of the time. For me, I've forgotten who I was saying this to. I think it might have been Michelle last night. Explain's like a curiosity kind of thing. If I see a select query, I just go, let's put explain in front of it and see what happens. Why would you not do that if it's relatively instant and you get to learn how MySQL works? It's like, does anybody who is domains? Like if you come across a new domain, you just who is it, just to see who owns it or just to see where they're registered or things like that. It's that level of curiosity for me. You've seen the explain. You know how you can speed it up. You add the index. You explain it again. If there was an improvement, if your query went from 600 seconds to 3, that's it, your work is done. You've just, in about 5 minutes, made orders of magnitude improvement with a tool that took, well, 40 minutes of a talk and then 5 minutes of using it. So here's the first example explain output. It's using there's a free data set with MySQL called Sakula, I think, or something along those lines, and it models a video rental or DVD rental store, which probably explains why the data stops in 2005. I've made some adjustments just to make the data interesting, but you should be able to download Sakula, import it, and explain all the queries and get the same answers. So here's the first example output, and the 4 key items that we're mainly going to be looking at in 99% of the jobs we're going to do when optimizing a query are highlighted in red. Let's just interpret what MySQL has found here. It found a where clause going from right to left. Great. MySQL estimates that it will have to scan through 16,000 rows in order to get our result set. What's interesting is that is a very rough estimate. There are actually 16,049 rows. The most important thing is, though, possible keys is null. There are no suitable indexes that it could have used to do this query, and as a result, key. It couldn't pick a key, which means it did a full table scan. Let's just do another quick example. So anecdotally, percent queries are bad. Everybody knows that they're slow, but we can now prove why that is. So we've done a select start from customer or last name like, and then a %, 1%, I don't know why I've done that. It couldn't use an index, even though I made sure that last name was indexed. So you can now prove what will work and what won't work, what will be quick and what won't be quick. So it had to do a full table scan. It scanned through all the customers. Now, obviously, when you've got 600 customers, it's not such a problem. If you've got 1 million, that's going to be a growing problem. A full table scan on a growing data set is only going to get worse and worse. And that's one of the advantages of Explain, is it lets you spot problems before they become problems. So a full table scan is usually a bad thing, but not always. But I'll just go into it. It's probably worth explaining just how MySQL's internals works very briefly. My interpretation is that MySQL is split into 2 layers. You've got the storage engine, which is the cool thing that you can switch in and out, but everybody uses InnoDB now anyway. And by the way, if you're not using InnoDB, use InnoDB. And then there's the MySQL server, which sits on top of that. And the idea is that the server says, get me all the people whose last name have 1 in it, and it's the storage engine's responsibility to come up with the goods as quickly as possible. Now, if the storage engine couldn't apply any indices or any magic to make that job quicker, it just goes, here's the full result set, you deal with it. And MySQL server has to use generic algorithms to filter out stuff. So as much as you can push into the storage engine, the better. If MySQL is having to do filtering or sorting or grouping by, your performance is going to be crap. So that's why a full table scan is bad, is because the storage engine's gone, your problem, not mine. And it's MySQL server's responsibility to filter through everything. So the things you have to consider with full table scans and why they're bad, they might not be in memory. If MySQL has to go to disk to load in the table to then filter through it, that's an extra overhead which makes it all unpredictable. If it has to go to disk, you have to assume that performance is going to be unpredictable because you can't guarantee your access to the disk. Full table scans aren't always bad. If you've got a list of countries, that's always going to pick from, that's always going to trigger a full table scan. So they're not always automatically bad. However, if you go into the database for a list of countries, shouldn't that be in memcache? Because that doesn't, I would hope that wouldn't change too often. If it does, I'm sure you could fix it. Right, so our first tool-backed index, we're going to apply some science to adding an index. So we're going to create a carefully crafted index, remembering the original query to do with list all payments on the 21st of August 2005. No indexes were found, so we've added one. It's called date only, and it's on the field called payment date. We explain again. So we haven't ran the query, all we've done is add an index and then explain to see what would happen. This is why you can do this locally, and you don't have to do all this live and ruin everybody's day. So there was a possible key, date only. The key that it used was called date only. And instead of scanning 16,000 rows, it only had to scan 671. So we've just had an incredible improvement, about 30 times if I think my maths is right there, probably not, but it's a big improvement. I'll just jump into compound indexes quickly. For those who aren't familiar, a compound index is an index over two fields. So what we see, Magma Digital, we do a lot of project adoption, I suppose is the polite phrase, where some projects somewhere their developers have left or they just don't want the headache anymore and we take on that headache. And a lot of time you'll see indexes per field, one index per field, no compound indexes, which to me immediately screams that they haven't really got an understanding of how indexing should work. So here we're going to make a compound index called superindex across payment date, customer ID and status. It's important to note that MySQL's index definitions are order sensitive. You can use them any order in the query, but you, for example, couldn't just use that index and say where customer ID equals 3. It would not be able to use that index. But if you said where payment date is such a day and customer ID equals 3, it would use that index. So you start building up a strategy for indexes to say, well, this is the most likely field, this is the next most likely field, and nobody really uses that field anyway, but we'll have it. Yes, so that's mainly true. Assume that that's true most of the time. There are some optimizations where you can join together two indexes, but let's pretend it's not true. It's just good practice. Here's a compound index example. So we've created superindex. It's just two fields. We're going to follow what I was saying there about using both components of the index contiguously, if you like, and that's chop that off the end. That's going to be entertaining later. The possible keys were date only, the first one we created, or superindex, and it's decided to use superindex because instead of searching now 671 rows, it's only going to have to examine 3. From 16,000, we're now down to 3. Now this problem is incredibly trivial. You could probably use full table scans and nobody would know, but the principles scale. You could do this with 1 million customers and the principles would scale. Oh, we know why it would choose superindex because it's better. But specifically, why would it choose that index? And the answer is something called cardinality. MySQL makes decisions on which indexes to use in a fraction of a second. It would be no good if it took 10 minutes to figure out which indexes to use, so it has to be a very quick rule of thumb for it to use, and that's called cardinality. And I copied that from Wikipedia. Cardinality refers to the uniqueness of values, and a column with the lowest possible cardinality would have the same value for every row. So what that means is gender, depending on the spread of your users, would be an awful index. Active, status, 0, 1, deleted, 0, 1, on their own would be bad indexes. Because when using an index, MySQL is going to say which index would chop out the most results at first pass. And if the answer is, oh, I can get rid of about 50%, MySQL is not going to use that index because it would just have to search through 50% of the rows anyway. There is apparently some overhead in using an index where it's just cheaper to do a full table scan, but that's not what we're looking for today. So show indexes in table name shows you the cardinality. So what we can see is customer.active has 4. I don't know why that's not 2. I don't know why. Payment date is 78, and the most selective index is right at the bottom there. If you provide payment date and customer ID, it could chop out 99.5% of the rows as being irrelevant and lead you to your answer. This isn't amazingly useful in and of itself, but it's interesting to observe MySQL's the way it handles stuff. So here, if you look at the query, I've got explain star from payment where payment is less than 300 and amount is 299. The query makes no sense. It's just illustrating a point. And so what MySQL's decided to do, out of 2 possible keys, it's going to use the primary key, i.e. payment ID. Payment ID, it will only have to scan 298 rows. So it makes sense why it would use that index. And then it will filter the remaining ones on the amount. So MySQL will have to filter through 300 rows to say where the amount is 297. That is acceptable. If we switch, we've changed one character in the query, less than to greater than. MySQL has decided to use a different index, even though it would have to scan 3,471 rows. So just to see why it decided to do that, if we force the primary index, so we give it a helpful nudge and say, no, really, I would like to use the primary index, it's estimating that it would have to scan through 7,400 rows. So MySQL has made a decision in a split second on the best approach to use based on the cardinality of indexes. And MySQL gets it right most of the time. It does get it wrong sometimes because we have some kind of outside knowledge. I don't know how that would be. But you can suggest an index to use if it gets it wrong. So explain works for joins too. There's some really simple examples here. So we're joining customer onto address using address ID. And again, chopped off on the right-hand side, great stuff. What it's decided to do here is it says, let's get every single customer record, and for each one, join on address. That's what that query execution plan is showing there. If we change one thing, left to inner, is anybody familiar with left joins and inner joins? A left join, the right-hand side doesn't have to exist, and on an inner join, the right-hand side does have to exist. So the previous query would have returned customers without an address. This will only return customers with an address. Just a quick catch up there. But just by changing it from left to inner, MySQL said, oh, actually, no, I'm going to start with address and then find customers. You've asked for customer joined onto address, but I'm going to start with address and join onto customers because to satisfy the inner join. So the main point here is that MySQL will monkey with your query quite significantly, and it can be confusing as to why it's doing it. And when you've got 5, 6, 7, 8, 9 joins, and it's coming up in a totally different order, the only thing you can do is treat them a pair at a time and just trust that it's doing a good job of, or well, distrust it if you want to go into more detail. I'm going to have to describe what's on the right-hand side of explain. Let's find all customers where there's no postal code. You would see that it was not able to use an index, and then it was having to do a full table scan. So if we add the postal code as an index and re-explain, again, chopped off, but you can just about see that it's scanning 4 rows rather than 6,700. So the principles for explain work on simple queries and arbitrarily complex queries. You just have to take each line one at a time and attack it and say, how am I going to index this to make this query better? And yeah, we've just improved efficiency by just over 100-fold. There are some specific behaviors that you can trigger in MySQL to elicit a performance. So where you're not necessarily just trying to get decent performance, but you're trying to get excellent performance, you can create indexes in such a way that will trigger a optimization by MySQL. So, again, in the extra section on the right-hand side that you can't see, there's a little note that says using index. And what using index means is that MySQL did not have to go, it got its results from the storage engine alone without going to MySQL. So if you remember before when we talked about the split architecture of the search engine passing up the results to the server for the server to filter through, well, if the storage engine, which is super fast and highly optimized, whereas the server is generic and general purpose, it didn't have to load in, it didn't have to go to the table, it didn't have to scan any rows. You got your answer just from the storage engine. Now, indexes are more likely to be in memory than tables, so that's why that's a good optimization to shoot for. And the reason we've been able to do that is because I said, well, I don't need the addresses, I just want the customers who don't have a postcode. So by not selecting the address table columns, it was able to use this optimization, if that makes sense. Right. Avoiding temporary table or file sorts. Temporary tables can either go to disk or not go to disk. File sort's the same thing. Although it's called file sort, it doesn't necessarily mean that it's gone to disk. Generally speaking, they're bad news if you can avoid them. A temporary table is exactly like it sounds. It couldn't produce the results without creating a brand new temporary table and then destroying it after it's given you the results. So find out how many postcodes grouped by city are blank. It's the same sort of fairly trivial query, but the killer here is grouped by city ID. That is causing a temporary table and a file sort. Because in order to group by, in order to stack together common rows, you have to sort it first. So that's where the file sort comes in, which could or could not go to disk. Depending on how big your result set, that may go to disk, and at that point you're in unpredictable performance. So right at the start of this project, we're going to head that off. We're just going to include city ID in our index. So basically we've got 3 possible keys to choose from. Ignore the first one, postal code, or the new one that I've just created, postal code city. And so it's deciding to use postal code city. And if on the right-hand side you would see it would say using index. It's avoided a temporary table and a file sort, and you've got a using index optimization back. Again, you could achieve that optimization in about 5 or 10 minutes. It's really, really quick to do. That was kind of the section on indexing strategy, if you like. There is another approach which, once indexing strategy kind of fails or can't work, is modify the query or data. Now obviously that might aggravate developers, but that might be what you need to do in order to get some decent performance out of your application. Let's say we have a report which says find all rentals which took place on a Saturday or a Sunday. Now, as far as I'm aware, the only way you could do that without changing the data would be to use a function, date format. So that there, select star from rental where date format, and then I'm formatting it like PHP's date function to come back with 0 or 6. That's going to do a full table scan. And the reason is, if you think about the table data for rentals, it's going to have to apply date format to every single row to find out if the answer is 0 or 6. There's no way you can kind of index your way out of that one. You have to, you've got 2 options. Pre-calculate Saturdays and Sundays in PHP. If you're only going to ask for the Saturdays and Sundays in a month, that would take a fraction of a second to pre-calculate the dates of the Saturdays and Sundays in PHP, and then what you would send that through in and use an in, which would use an index. So that's one sort of optimization by changing the calling code application. The other option that you would have would be to summarize the 0 to 6 value in another column. Now obviously that's got an inherent problem. How do you keep those values up to date? As soon as you insert a new rental, you're going to need to make sure that last column is up to date. And whether you do that in PHP or using triggers is your call, but it's an extra overhead for the sake of query performance. But those are 2 ways to make sure that you could use indexes to get your answer quickly if that table started to grow larger than 16,000 rows. One of the sort of proud and ashamed moments, if you like, of my past is about 7 years ago, I was working on a large hand-rolled e-commerce system. Now, 7 years ago, I think we were on MySQL 4, maybe 5, I can't remember. And Apache Solr was probably like a research stage. I don't know, it just wasn't on the radar. We had to do an in-house solution. Thousands and thousands of products. This is an absolutely massive outfit in the UK. And every product, the new interface was to be tagged and categorized, and things could be in multiple categories, things could be in multiple tags. And the idea was that you would search by category and then search within that category, or search by tag. So on the left-hand side, you'd pick whatever kind of category of product or tag that you wanted, and then search within that. And we got to a stage where the query worked. It had about 6 joins in it, and it was awfully slow. And when we say awfully slow, oh well, that was loud. When we say awfully slow, you know, half a second. But for for an e-commerce site which has thousands of people hitting it, half a second becomes unacceptable pretty quickly. But again, that goes right back to the start with: is it necessary to if 60 seconds is acceptable because it's in the middle of the night, move on. Why make life difficult? But here, half a second was too slow. So the solution was to create a summary table, denormalizing the data. And I like to think of denormalization as a process of making vertical data horizontal. Because if it's horizontal, you can index it and search quickly on it. Whereas if it's vertical, you're back to filtering. So every product, its availability, stock level, all that sort of stuff, was summarized into a very, very wide table. I forget whether we used triggers or lazy cron jobs. We didn't re-index all the time because just in the middle of the day it didn't make sense. I think maybe what happened is as you added a new product, it may have built up the extra row that it needed. I can't exactly remember, but those are all three possible options for summary tables, either a cron job every 5 minutes, triggers, so it's kept built up for you, or do it ad hoc whenever you need it, and then once a day in the middle of the night refresh the index to make sure there's no missing items. And the final part was totally abuse full text indexes in MySQL. And what we did, MySQL full text index can only index underscores, letters, and numbers. As soon as you put any sort of punctuation in there, it kind of breaks it and it doesn't work quite right. So we were trying to think of a way around that, and this was the solution that we came up with. So in order to find out everything that was tagged with the following tags in the following category and the following text, we used MySQL's full text index to say tag 2 must be in the result set and tag 56 must be in the result set, and then product name and description. And that came back in sort of hundredths of a second. So it's a balancing act. Which is most important, lightning fast or the overhead and sort of shame of using summary tables? There's a lot of stuff that we haven't been able to cover today. For example, indexes are so great, why don't we index everything? Let's do every combination, let's make all these massive indexes and keep everything as highly selective as possible. And the problem is that maintaining index is hard work. Every time you do a delete, update, or insert, an index has to be modified. And if you've got 20 indexes to update, it's going to make inserts and modifications very slow. So you have to really pare back and do the bare minimum of indexes to achieve what you want to achieve, and consider very carefully about adding a new index once you've got once it starts to become a problem. Once the overhead of maintaining the indexes is too much. Kind of similarly, index prefixes. You don't have to index the full string. You don't have to index, if you've got a last name and it's a 255, varchar 255, you don't have to index all 255 characters. That would be stupid. That would be far too big an index for the performance benefit. What you can do when you're defining an index is you can say, I want to index the first 4 characters. And that might be good enough to get you the results quickly without having a gargantuan index by the end of the week. There is it might be in high performance MySQL 3rd edition. There's a really neat little trick for finding out what the best possible prefix would be. I think he just takes the minimum and the longest character in a result set and then does some kind of average crazy math to find out, right, that's the sweet spot. You should index the first 6 characters of this column. There are a bunch of other index optimizations that you can take care of and target. You can shoot for an index optimization. Index merge is one that came out in, I think, 5.5. What used to happen historically is you couldn't have a query that said, I want where address is like this or custom name is like that. MySQL would say, you've got to pick one or the other index-wise. I think, as of 5.5, there's index merge optimizations, which allows it to intersect across 2 indexes. And you'll see in extra it says using index merge using intersect, I think is what it says. And you can target those. You can do your indexing strategy knowing that you'll hit that optimization. There are lots of cheap hacks that you can do to get decent performance out of an index. For example, one thing it can't do is have 2 range checks. A range query is where you'd say date is greater than this. That's a range scan for the index. If you've got 2 of those in a query, it will end up it can't use both of those range scans in an index. And the example in high performance MySQL is he says users who logged in the last 7 days and are aged between these two ages, between 18 and 25. It's some kind of social media site example. And what he says is, well, 2 range checks, you can't use an index. Whereas if you said logged in the last 7 days and the age is either 18, 19, 21, 20, 20, up to 25, that will work, that will use an index. So there's all sorts of silly little optimizations which I think are trying to be worked out by the MySQL team. They're trying to say, you know, stop you having to do silly hacks and workarounds, but that's what's necessary now. Deferred joins is if you Google deferred joins and you're having problems with limit performance, so you've got you're 500 pages into 1,000 pages or something like that and it's getting very slow. If you Google something called deferred joins, that's a very neat trick. Index condition pushdown, which I've tried to understand about 6 times now and I can't figure it out. I think it's an optimization that you basically get for free in 5.6. MariaDB 5.5, MySQL 5.6. There's a new optimization called index condition pushdown, and whether you like it or not, it happens on your query, and it's pushing more work into the storage engine than you would have got previously. You can turn the optimization off if it's causing you problems, but again, everything is about pushing more work down to the storage engine. There are a bunch of resources. But these are probably the only ones that I've really ever come across that are any good. I think there's one called something like hackmysql.com. I haven't listed that here, I should have done. Section 882 of the MySQL manual, explain output format, tells you what every column means. So for the columns that were off the right-hand side of the slide, you can go and look at that page and find out what those would mean. It explains every kind of index type, index scan type that it can use. It explains every kind of index optimization that is possible. It's a really good and straightforward documentation. It's very, very easy to understand, and especially when the cycle for index optimization is explain, don't like the look of that, add an index, did it improve it? It's very easy to get used to using explain. MySQLperformanceblog.com. I haven't been on there in quite a while. I used to have their RSS feed. The guy, Peter Zaitsev, I think is his name, or Baron Schwartz, they just come out with very silly sounding scenarios like, oh, we put 10 million rows into this table and 2 million rows into this table, and this was an interesting performance bottleneck. We also we bench tested this on a 64 core server. They do things that I don't think the rest of us would either have time to do or the budget to even begin to look at. So that's always worth looking at. Yes, everything that Picona ever made is a good resource. Once you install their tools, there's about 30 tools that they've got, and there's like there's stuff for checking that your replication's up or how far behind it is. There's stuff for visual explain. It does a little ASCII tree trying to explain how the execution plan worked. There's PT Query Digest, which is brilliant. Incidentally, and this would have been better if I had my presenter notes, PT Query Digest can work on a stock MySQL installation. You get less information, but it still works. So you just point it at your slow query log, and it gives you the worst offender. And you can then go and tackle that. The last resource is MySQL Workbench 6 Visual Explain. I've tried it a couple of times and you think that's really cool, but I don't know how to use it yet. I don't know. I'm too used to the classic table output to really make use of this cool diagram with lots of arrows going between stuff. It's a bit. It doesn't make a lot of sense, but it's very cool. I think that's about it. Has anybody got any questions? Nope. Okay. Oh, I nearly swore then on camera. Jeremy, what's your talk number? 49. Mine's 8848. 8948. Joined in /8948 is my talk number. Thanks very much.